Hi, Rumaiza. Hi, Rumaiza. We are meeting after a long time, right?
Yes, sir.
Okay, so do you remember what we studied last time?
No,
Anyone?
sir.
So we can scroll back and see what did we studied last time. So actually we are studying the chapter 10, right? And chapter 10 is about work and energy. So we first define work. Okay, so here it is work. So how would you define the work? If I'll ask you, what is work done or what is work? Anyone? How we will define the work? What is work? Anyone can define? Rumaza, what about your headphone? It's not working?
Yes, sir.
So what is work done? What is work done? We already discussed what is work done, right? So will you say what is work done? What is work done? What is work done? If you apply a force on an object, suppose this is an object of mass m. If you apply force over it, okay, and this object makes a displacement, suppose now this object is over here, okay, on applying this force, the displacement is say x, displacement is s. So this move from here to here, this is s. So work done is force times displacement. This is work done, right? On applying a force on an object, if object moves by a distance s, then the product of force and the displacement is called work done. Okay? For work done, the displacement is necessary. If there is no displacement upon applying the force, the point is if there is no displacement upon applying the force upon applying the force applying applying the force. Okay, if there is no displacement means s is 0. Okay, if there is no displacement upon applying the force, there is no work done. There is no work done. Clear? So it is being said that work done is force, we apply force, but displacement is 0. So it is F into 0 is 0. It is same like that if there is a wall. Okay, this is wall. This is wall. And you are applying a force on a wall. So wall will move or not? Please respond and open the camera. If you are pushing a wall, okay, of your room, so there will be any displacement in the wall?
No.
Rumaiza and Riaz, no. So if there is no displacement, so F into 0, you are applying the force. You are pulling the wall. You are being exhausted. You will be sweating if you are pushing the wall, but wall is not moving. So in the term of work done or in the term of physics, you are doing no work. Even you are pushing the wall from morning to evening, you are getting tired, but still you are not able to do the work. Okay. So this is the definition of work done. There are n number of definitions. Okay. If a potter is keeping the weight over his head and he is standing from morning to evening, he will, what can I say, he get tired. But as he is not moving, the object is no, there is no displacement in object, so there will be no work. So for the work done, either the force should be non-zero or the displacement should be non-zero. So if there is, if you don't apply a force, there will be no work done. So first point is this, and another point, if there is no force, no applied force. Applied, I'm writing it applied. If there is no applied force, it implies no work done, right? No work done. So for the work done, there should be some displacement or there should be force. But displacement is necessary. If you apply force, there should be displacement. So you guys not revised now, right? I think you are not revising. So we did this problem as well. We did this problem as well. We defined the energy. We defined the forms of energy as well. We defined the conservation of energy. We defined the kinetic energy as well. We define the work energy theorem. So what is work energy theorem? So work energy theorem says that, anyone know what is work energy theorem? Work energy theorem. Anyone know what is work energy theorem? Rumaiza, are you there? Riaz, at least you should open the camera, na? Rumaiza is not opening. This is also not fair, but at least you should open the camera. So what is work energy theorem? Riaz, you don't need any parda. Okay. I don't know. Yeah. So what is work energy theorem? It says that you have a ball, right? This is a ball of mass m. When you go to ground, you hit it. Okay, you hit it. This is a ball. So when you hit it, it gains a velocity. Okay, it gains velocity. Gains velocity. If it gains velocity, so it moves with velocity v. So it gains a kinetic energy, half of m into v square. This is kinetic energy, right? So upon hitting means that you did some work. When you did some work, that work is being transformed into the energy. This is kinetic energy. So if you do some work, then work will be transformed into kinetic energy. So work energy theorem is that work is equal to energy. Energy means work will be transformed into the form of energy. Work will be transformed in the form of energy. Or we know we have two type of energy, either kinetic energy or potential energy, I dot T. That is in kinetic energy plus in potential energy, right? So that's why we solve this equation. Note it down or take the screenshot. That's why when we solve this equation, v square minus u square is equal to 2s. We multiplied it by m and divided by half. So we see that half of mv square is kinetic energy. V is the final velocity. So it is final kinetic energy. This u is initial velocity. So corresponding to this, we have initial kinetic energy, or here it is mass acceleration into distance. So mass into acceleration is force, or force into displacement is work done. So here it is kinetic energy into work done. Okay, so in this case, there was only kinetic energy. If there is potential energy, we will add potential energy also. So whatever, again, I'm repeating, whatever work you are doing, that work will transform into kinetic and potential energy. Understand? What is work energy theorem? The work energy theorem is that whatever work you will do, that work will transform into kinetic and potential energy. Clear? Yes, is clear?
Yes.
What is work energy theorem? Rumaza, tell me what is work energy theorem? Rumaza is sleeping. So Reyaz, what is work energy theorem? Reyaz, what is work energy theorem? Rumaza, are you there?
Yes, sir.
So what is work energy theorem? I said na, make the note. The work energy theorem. Okay, work energy theorem is that whatever work you will do on an object, that work will transform into the form of energy. That energy means kinetic plus potential energy. You guys understand and note it down, okay? Unless until you want revise, there will be no benefit
Yes.
of the class.
Sir, can you write the definition?
Sorry?
Can you write the definition of work energy?
Work energy definition. So definition is whatever work we will do on an object that will transform in the form of energy. That is kinetic energy plus potential energy. Clear? Okay, so further we will explore the work energy theorem, and then you have to answer this question. So I am keeping this question for you. Before that, I will write another form of kinetic energy. So we all know that v square minus u square is equal to 2a into s. So if I will write it in another form, then it will be v square minus u square by 2a. Clear? Now, work done is force into displacement. Force into displacement s. Force is what? Mass into acceleration into displacement. So keep that mass into acceleration as it, and now put s, this displacement over here. This is v square minus u square divided by 2a into s, right? Now cancel this a with this a. Why I am writing s over here? S means v square of minus u square by 2a. So it is m by 2 into v square minus u square. So further, if we will write it, it will be half of m v square minus half of m u square, right? So half of mv square or half of mu square, v is the final velocity and u is the initial velocity. That's why half. It is final kinetic energy, final kinetic energy, final kinetic energy minus initial kinetic energy. Initial Ke means kinetic energy. Did you understand this? This was the work done. This was the work done, and that work done transformed into the form of energy, right? Understand or not? These steps are clear. Ramaza and Riaz, these steps are clear. These steps are clear or not?
Yes, sir, clear.
Riaz, what about you?
Yes, sir.
We all know this equation from very early days, okay? And we know this definition from this chapter. So I substituted S from this equation, and we all know the force is mass time acceleration. So just put the mass time acceleration over there, and we got that work done is change in kinetic energy. So now I will write it. Final kinetic energy minus initial kinetic energy. This means change in kinetic energy. Change in kinetic energy. So work done is nothing but change in kinetic energy. Work done is nothing but change in kinetic energy. So you know the change in kinetic energy, you will put that equal to the work done, right? And the kinetic energy is always half of mass time velocity square. Kinetic energy is always half of mass time velocity square. This is the kinetic energy. Any confusion in these calculations?
No, sir.
So if you understand the concept, then this question is waiting for you. This question is waiting for you. The kinetic energy of an object of mass m moving with velocity of 5 meter per second is 25 joule. What will be its kinetic energy when its velocity is double? What will be its kinetic energy with its velocity is increased 3 times? So we all know the kinetic energy. So here velocity is being changed. Its velocity is doubled, and then its velocity is 3 times. So in all these two cases, you have to calculate the kinetic energy. Can you solve it? Did you understand the question? Riyaz, did you understand the question? No. The kinetic energy of an object of mass m moving with velocity 5 meters per second is 25 joule. So the first part of the question is simple. What it is being says, first of all, I'm changing the pen because here is no space. So I will write in this space only. So we know that kinetic energy is half of mv square, right? So here the mass is m, velocity 5 meter, and kinetic energy. So mass is given, velocity is given, kinetic energy is given. So it is saying that kinetic energy is 25 joule for for an object of mass m. Mass is not given, and velocity is given as 5 meter per second, 5 meter per second square. So from here we will get the concept expression for mass. So it is 25, it is half, it is m, and 5 into 5 is again 25. So 25 cancel, m is equal to 2 kg, right? Clear first part? Now what will be its kinetic energy with when its velocity is double? So the part second is find the kinetic energy if velocity is 2 times the initial velocity. That we say that 2v initial, right? So for kinetic energy, we need mass and velocity. So from here, we got the mass, and from this data, we got the velocity. So now can you solve it? Maiza, did you get the concept to solve this question?
Yes, sir.
Okay. So try to solve it. Are you able to do it? Maiza, did you get answer?
No, sir, just the last.
Okay. Riaz, any progress?
We're doing.
Okay.
I got the answer as 225 joules.
Okay, 225 Joule. What about Riaz? So see, I'm going to solve the first part, okay? And the next part you have to do, okay? So for that, I am removing the space beneath the question. I'm removing this. Okay, no problem. I'm removing this. See, what the solution we have? We got mass is equal to 2 kg. We got mass is equal to 2 kilogram. Okay. V is given as 5 meter per second, right? So in part 1 that it is say that V becomes double. So this say prime, this is 2 time V. So it is double. So double means 2 into 5. So this will be 10 meter per second. So kinetic energy prime corresponding to this is half of mv is prime square. So this is half, m is nothing but 2 kg, and this is 10 square. So 10 into 10 is 100. The unit of energy is joule. The unit of energy is joule. So Rumeza, your answer was different, right? Rumeza, your answer was different.
Yes, sir.
So did you understand where you were doing mistake?
Yes, sir, understood.
What about Riaz? So you do the second part. Okay, what will be the kinetic energies? Velocity is increased 3 times. Riaz, did you get the answer? Or did you understand
Yes.
the question solution?
Yes.
Okay, then move for the next part.
Let me note the answer.
Okay, you got the answer? Next part?
So I'm writing
Okay, do it.
the first.
In physics, numerical is important, okay? So it is important to understand the numericals. If you understand the numericals, you will be able to do the cons theory as well. So instead of going for the next topic, I'm going to present the next problem. This is the next question in the space. So before that, you solve this. Any progress? Any progress? Any progress, Riaz and Rumeza? Any progress? See, this time the kinetic energy is increased to 3 times. So it will be 3 times V. So 3 times V means 2 into 3. So it will be, sorry, 3 into 5. So it will be 15. So the kinetic energy will be half of mv square. So it will be how much? 15 ka square. And 15 ka square, you all know. So I think you guys are not understanding. That's why. See, I'm doing the second part. Okay. When v is 3 times, so we all know that 3 into 5, this is nothing but 15. So kinetic energy will be half of m into v. This time I'm writing it double prime. So double prime square. Mass is fixed 2 and double prime is 15 square. So this to this cancel. And 15 square is how much? 15 into 15. 225, right? 15 square is 225. So it will be 225 joule. That's it. So Riyaz, how you are doing? You are not understanding, I think. ऐसे कैसे काम चलेगा? ऐसे कैसे काम चलेगा बताओ। कैसे होगा? हाउ यू विल सर्वाइव? How you will face the exam if you are not able to do the questions? There's no excuse, okay? You have to revise it well. I don't think you guys are revising. Without revision, you can't learn anything. I'm not happy with your performance. Now try the next question. 10.4. I'm not happy, really, I'm not happy with your performance. You are not able to do the questions. Really not happy. Okay, so I think we didn't study for a long time, that's why you might miss. But in the next class, you should be knowing all the definitions. Okay, all the concepts. Oh, no. Are you able to do the example number 10.4? What happened? Did you got the solution? Riaz, are you able to solve the question 10.4? Rumeza? Okay, 2. See 10.4, how we will solve. As we shown the relation over here, this relation is, where is this? We erase that relation. So we have to write half of m b square minus half of m u square, and this will be equal to work done. So this will be equal to work done. And you know that v is 60 meter per hour, kilometer per hour, and u is 30 meter per hour. This is given over here. So just do it. First change 30 kilometer per hour into meter per hour. Kilometer per hour to meter per second. Similarly, 60 kilometer per hour to meter per second. And you have the mass. So calculate this value and this value. This will be the work done. Got Riaz? Riaz, did you get the concept? Rumeza, what about you?
Yes, sir.
Okay, so go and revise all those concepts. Solve this question in front of me and tell me what is the answer. Work done is nothing. We already said that work done is nothing but change in the kinetic energy. So final and initial velocity is given, and we know how to calculate the kinetic energy. Kinetic energy half of mv square. So we have just substituted the relation. That's it. Should I solve this question? You will do yourself. So first of all, mass is given as 1500 kilogram, and u is 30 kilometer hour inverse. So this will be 30, 1 kilometer is equal to 1000 meter, and 1 hour is equal to 60 into 60 second. So 10, so 10, 10, 10. So it is I did one thing out of order, so I'm going to correct that. I want erase this 0. I will keep this 30 as it. I will keep this 30 as it. So 110, so 10. So now I will solve that. This will be 5 2, 5 to the 10, and 5, 6, 3 to the 6. So it is nothing but 3, and it is 5 divided by 6 into 3. Now I will solve this. 3 times 10. So it is nothing but, again, half. This will be 5. This will be 3. So it is nothing, 25 over 3 meter per second. Similarly, you may solve 60 kilometer per hour. So 60 will be nothing but 60 into 5 divided by 6 into 3. So 6, say 10 times, then it is nothing but 50 over 3 meter per second. Just substitute the value and you will get the work done. So let me do the next part. I always lack of a space. So this is half, and is how much? 1, 5, this was 0, and I'm taking b minus u. So v is 50 over 3 square minus u is 25 over 3 square. So this is, and we all know a square minus b square is a plus b into a minus b. So I'm going to do this only. Okay, take the note. Half 1500 and 50 over 3 a plus b into 25 over 3, then a minus b. 50 over 3 minus 25 over 3. Now you solve this. This is nothing but half into 1500, and this will be 75 over 3, and this will be 25 over 3. So now it's your time to solve the question. This will be 500, and solve that and you will get answer. Got Riaz and Rumeza process? Now you have to do this calculation only. Clear? Take the screenshot. We'll meet next week. Okay, so Rumeza went, Rumeza left. Riaz, what about you? Did you understand the questions of today's class? Riaz, did you understand today's class? Yeah. Okay, then I'm closing the session. We'll meet next week. Okay, bye.